All right, welcome back. Hopefully you guys are all doing well, staying safe. Let's begin today's class. I'm looking for a few people. I'm looking for Bellman, looking for Micaiah. I'm looking for Kim, Joseph, Tristan, and Philip. If you're here, please let me know. Hey, Micaiah. Again, Alex, Leonardo, Kim, Joseph, Tristan, and Philip. If you're here, please let me know. All right, let's get rolling. Busy class today. A lot going on for today's class. You do need scrap paper. You do need a reference table. Feel free to use a calculator too for today's class. Let's see what's happening. Quote of the week: success is dependent on effort. Effort, effort, effort. You put the effort in, you'll get something out of it. If you're trying, you put that effort in and you try, you fail sometimes, you learn from the mistakes, you'll be successful. Take that with you. Put the effort in. If you have the ability to put the effort in, if you have the drive to put the effort in, you'll be successful. Effort's key. If you don't have that effort, if you cheat through things, then the success is not going to always come with it. You put your own effort in, you'll get something big out of it. Put the effort into college, you'll get the results out of it. Put the effort in this class, you'll get something out of it. Your post-test is tomorrow. Your post-test is going to be 32 multiple choice questions. You can use a reference table, you can use a calculator, you can use scrap paper. It's 32 multiple choice questions for the post-test. So I'm giving the entire period block tomorrow. So you have both periods to complete it. And that has to be completed. It's going to be graded. Act as if this is your Regents exam. It's graded as a test grade. Let's see if you learned something in chemistry class, Regents chemistry class. It's a tough class. The toughest Regents science course you're going to take at Proctor. It's a lot of content. Did you learn something in this virtual world of learning? I know it's different. It's new. I think it'll be over next year, but it was a year of virtual learning. Did you learn something out of it? Maybe it won't be over next year. So again, 32 multiple choice questions tomorrow. It's a post-test. It's graded. It has to be completed. What's going to be on the test? It's going to be anything from units number 1 through units number 10. The only exception for unit number 10 is going to be topic number 4 and topic number 5. So functional groups, not on the test, or organic reactions, not on the test. Again, units 1 through unit number 10, we've been reviewing for this post-test for a couple weeks now. We went through each of the units, 1 through 9. We'll finish up 9 today. Units number 10, we're going through in class, so I'm not reviewing it for a post-test review. Today's Tuesday, May 25th, 2021. It's a day 1. We're going to continue on with organic chemistry today, but before we do that, we will review unit number 8, which is redox, and unit number 9, which is acids and bases and salts. After we're done with that, we'll go through topic number 4, which is naming organic compounds. Again, you want scrap paper, you want pencil, you want a calculator, maybe reference table for today's class. We'll just go through some nomenclature and some guided notes today. The examples we'll analyze in the note packet, but not for the Google Forms. So the only thing we're doing for today looks very small, but it's going to be number 1 and number 2. Next class is a post-test. There's no school on Friday. There's no school on Monday, May 31st. I think I did the countdown today, and there's like 15 more full days of school. And there's 13 more days of in-person learning. So again, the 18th and the 21st, I think those are the right dates. Those are going to be remote days. Oh, here's my little, put this up on the screen for everybody. Hey, Alex. Please try to get here a few minutes earlier. Okay, here's the calendar for June. I know we haven't had the calendar for June, but let me pull it up on the screen quick. Here's the June calendar and a couple key dates to know. So I told you that there's no more school on Friday, but Friday, June 11th, there will be school. There's definitely going to be school on Friday, June 11th, close to the end of the year. Your final exam will be this week, somewhere in that week. So June 7th through the 11th, somewhere in that week. No school on the June 4th. There's school the 11th. And the 18th is going to be a remote day. The 21st is a remote day. The 16th is the last day of school in person. Other notes, other dates to know. Prom. Prom's going to be the 11th and 12th if you're going. And graduation is going to be the 17th through the 25th for an older brother or older sister. I don't have any more details regarding prom. But post-test is definitely tomorrow. Post-test tomorrow. There's a calendar. There's the important dates that you should be aware of. What else do we have to talk about? Let's talk about the COVID report. Let's just analyze that really quick for a second. Last day of remote is going to be the 21st. So 18th and 21st, it's like extra days of school. What I plan to do there is probably just analyze a video on nuclear chemistry and a video on maybe organic chemistry. Let's analyze the COVID report. It's been a while since we saw that. I just want to look at something really quick for a minute, just a hot minute. Number of cases of COVID in Oneida County today is 155. Cool. Awesome. Let's check out this curve too. The curve we analyzed all year looks amazing. That curve, you look at the last few days, look at the month of May, you can see the trend. You can predict the trend. We know where it's heading. Hopefully it stays down there. So besides like 2, I guess, bad days in May, 2 bad days, we'll say it's a bad day here and a bad day there. Besides those 2 days, that trend of May looks like a solid month. We're definitely decreasing. Last 2 days, we did have 8 cases per day. So we're in the single digits for number of cases. This year, started off in September, and then we started analyzing this chart, this curve throughout the duration of the year. There's a year of chemistry. We analyzed it basically till May, and then I said, I'm done with it. Gotta get some content through. Things started getting more normal. We're back at it. So again, just wanted to take a look at that. It's been a couple weeks since we did see it. It's heading in the right direction. Let's go. Let's get right to the guided notes. Let's get through the review for redox reactions and acids and bases. Please open up the review in Google Forms for units number 8 and unit number 9. Please open it up. Review, unit 8 redox and unit number 9 acids and bases. There are 12 questions here regarding acid bases and redox. Maybe you want to open up your guided notes on both those units too. So maybe you do. This is your period, unit number 8 redox, and I have unit 9 already pulled up for you. You could open up your own notes. Hopefully there's something there. If there's nothing there, that means you didn't do your notes. This is like your textbook for the year. So in redox, let's review this quick. Redox, we talked about assigning oxidation numbers, redox reactions, half reactions, voltaic cells, and electrolytic cells. I don't think topic number 3 is going to be on the post-test. I'm pretty sure there's no half reaction questions on the post-test. But everything else is pretty much fair game. I don't think there's actually electrolytic cells, but we'll review that too. Let's see. What do we talk about in redox reaction? Redox, oxidation, and reduction. Topic number 1, we talked about assigning oxidation numbers. We said oxidation is going to be the loss of electrons or the gain in oxidation number. Reduction is the gain in electrons or the decrease in oxidation number. We looked at an example of an ionic compound of MgNO. We revisited this. We figured out how to come up with the oxidation numbers. And then we figured out a formula. We looked at a molecular formula and empirical, which means simplified. We looked at the Lewis dot diagram for an atom of Mg and an ion of Mg. We looked at a Lewis dot diagram for an atom of O and an ion for O. An atom's charge equals 0 because protons and electrons cancel out. Ion's charge equals a negative or positive, meaning it lost or gained electrons. We said redox reactions involve the loss or gaining of electrons, loss and the gaining of electrons. We looked at assigning oxidation numbers. We talked about the phrase Leo says Ger. Loss of electrons, oxidation. The gain of electrons is reduction. Then we looked at these rules. I told you to memorize these rules. If you did, it'd make the unit a lot easier. If you never memorize the rules or don't know how to use these rules, then the rest of the unit was really tough for you. We looked at the rules. We said, rule number 1, an atom's charge equals 0. Why? Protons and electrons cancel out. We said the ion's charge equals its oxidation number, meaning it lost or gained electrons. Rule number 3, we said group 1 metals have a charge of +1 in a compound, and group 2 metals have a charge of +2 in a compound. We said group number 17 for rule number 4. Group 17, halogens have a charge of -1 in a compound. Rule number 5, there's a rule for H. Do you know that rule? Rule number 6, there's a rule for O. Rule number 7, the sum of oxidation numbers equals 0. And the last rule, rule number 8, the sum of oxidation numbers in a polyatomic ion equal its charge. We analyzed so many different examples of assigning oxidation numbers. There's 3 in the notes. There's probably 10 more, the examples that we did, and the exit pass. Topic number 2, we talked about redox reactions. We figured out how to identify if it's a redox reaction. If an element is uncombined on one side of the equation and appears in a compound on the other side of the equation, it's going to be a redox reaction, meaning it lost or gained electrons. Redox reactions could be addition, they could be decomposition, they could be single replacement or substitution. A double replacement reaction is not redox. We took a chemical reaction, we analyzed the chemical reaction, we figured out the oxidation numbers for each element in the compound. We set up a partial half reaction. We did that again. We figured out which one's losing electrons, which one's gaining electrons. We figured out which ones were spectator ions. Agents won't be on the post-test. We talked about half reactions. You could check that out if you want to review that. We talked about voltaic cells, topic number 4. We drew a voltaic cell. I did a demonstration under the Elmo on making a voltaic cell. We know a voltaic cell is going to have 2 different chambers. It's going to have electrolytes, electrolytic solution. It's going to have 2 different metals. It's going to have a salt bridge, which allows ions to flow. There's going to be a copper wire. There's a voltmeter. We should be able to label this thing still. We should know electrons flow from anode to cathode. Electrons flow from anode to cathode. Electrons flow from anode to cathode through the copper wire. We should know how to label an anode. We should know how to label a cathode. We looked at table J to interpret an anode and a cathode. You should figure out which one's losing electrons, which one's gaining electrons. You should figure out Leo says Ger, red cat and ox, all that stuff that applies for a voltaic cell. You should know the conversion of energy. How is energy converted? It's going to be chemical to electrical. So all that stuff we talked about for voltaic cell. And then we talked about another example. You guys figured out all the information about another example for a voltaic cell. Topic number 5, we talked about electrolytic cell. Electrolytic cell, we took a nickel, and then we took the copper penny, and we took the copper off the penny and plated it onto the nickel. We copper plated the nickel. We did a demonstration in class. So the electrolytic cell, what do we know? We need a battery. We have 1 chamber, 1 cell. You have 2 different metals, and we connected the metals to the battery. The battery determined which one's the anode and which one's the cathode. The cathode was negative, the anode was positive. From that, we figured out red cat and ox. We figured out Leo says Ger. The electrons flow again from anode to cathode. Electron flow goes from anode to cathode. Anode is the positive charge. Electrons flow from anode to cathode. Electrons are negative. If they flow from anode to cathode, this nickel was going to be mainly negative. This penny was going to be a positively charged penny. Electrons flow from anode to cathode. We could see what happens. Electrons are negative. This nickel's negatively charged. It's going to attract some positive charge from the nickel. I'm sorry, from the penny. And it's going to build on top of the nickel. We talked about the conversion of energy for electrolytic cell. It goes from electrical to chemical energy. We analyze a electrolytic cell. The last page is like a little cheat sheet for voltaic versus electrolytic cells. Hopefully you did this. Hopefully you could figure out the differences and the similarities between both cells. That's unit number 8, redox reactions. Next unit, we talked about unit number 9. We talked about acid, bases, and salts. We talked about topic number 1, Arrhenius acids and bases. Topic 2 is Bronsted-Lowry. Topic number 3 is Lewis theory. Topic 4, we talked about pH scale and the indicators. Topic number 5, we talked about neutralization and titration. I wouldn't expect to see any questions on topic number 2 or topic number 3 on the post test, but units 1, 4, topics 1, 4, and 5, there's a good chance you might see a question regarding those 3 topics. We talked about Arrhenius theory of acids and bases. We said Arrhenius acid is an H+ or hydronium ion. Arrhenius base is a hydroxide ion. We looked at some common acids on the reference table. We looked at some common bases on the reference table. Bronsted-Lowry theory, you could check that out. Again, I wouldn't expect to see a question on Bronsted-Lowry, but Bronsted-Lowry acid is going to be hydrogen ion donor. The base is going to be hydrogen ion acceptor. We looked at this example. We figured out which 2 are most similar. We figured out the pairs for both. Lewis, overlooking. There's not going to be a question on Lewis. We talked about pH scale and indicators. We did a demonstration on indicators. We looked at a couple different indicators there. We'll look at a question regarding that too. The pH scale, we should definitely know inside and out. We should know the pH range. We should know what makes an acid, what makes a base, a strong acid, strong base. We should know what makes something neutral. Spent like a whole class talking about the pH scale. We talked about neutralization, where an acid plus a base yields salt plus water. And we talked about titration. We figured out what titration is. Neutralizing something. You're mixing an acid and base to make salt and water. But we also talked about the formula for titration. The molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. There's a couple examples that we analyzed. And again, the last page of the notes is our little cheat sheet for the entire unit for acids and bases. We went through that. Let's go through some examples now. Here we go, review. Question number 1, review Unit 8, redox reactions, and Unit 9, acid, bases, and salts. Question number 1, all redox reactions involve what? Please put the answer in the chat. What do you think the best answer is for number 1? Redox reactions, oh hey Bellman. Redox reactions involve what? Please record your answer in the chat. Oh, Bellman is here. Thought I marked you here. Yes, Joe, all multiple choice. All redox reactions involve, thanks, Zin, redox, reduction, and oxidation. Reduction and oxidation. What's reduction and oxidation? When I think of reduction and oxidation, I think of Leo says grr. Why? You have reduction and oxidation. Loss of electrons is oxidation, and the gain of electrons is reduction. One, the best choice is going to be both the gain and the loss of electrons. One's going to be choice C, best answer. Zin's the only one that got that right. Nice job, Zin. Thank you. He's the only one responded to. One, the best answer is going to be choice C. Number 2, in the reaction with 4 moles of HCl plus Mn O2 yields MnCl2 plus 2 moles of water plus Cl2. The manganese is what? Do you remember how to do this one? So you have a question on the post test. You're trying to answer this question. You're trying to think about what you know about chem class, and then hopefully connect. You're trying to figure out the oxidation numbers for manganese. So manganese, the symbol for manganese is Mn. So it's going to be that compound. And it's going to be right there too. We don't care about anything else but manganese for this question. We only care about Mn. So let's get rid of the other garbage. I don't care about it. We want to figure out the oxidation number for manganese. Can you still do this? All right, so the first one up, manganese, we have MnO2. When we assign oxidation numbers, when we're trying to figure out the oxidation numbers for an element, I told you set up the equation. I said, how many moles of that element do you have? How many moles of Mn are there? How many atoms of Mn are there? There's one. If you look on the reference table, there are several charges for manganese. So we're going to call that X. Or there's no rules for manganese. Number of atoms, oxidation number. Next up, let's look at oxygen. How many moles of oxygen? There's 2. What is the charge on oxygen? It is -2. So use your reference table. There's 1 charge for oxygen. There's a rule for oxygen. In a compound, it's going to be -2. This whole thing has a sum equal to 0. Rule number 7. Could you still set that up? If not, revisit your notes, revisit the video if you need to, and do it. Solve for x. X plus -4 equals 0. X equals +4. Manganese charge for the reactant equals +4. O's charge was -2. All right, manganese is going to be +4 in the reactant. Let's check out the product side of the equation. Product side of the equation. MnCl2. That's a compound. We're trying to solve for the oxidation of manganese in this compound. Again, same approach. I would say how many manganese are in that compound? You would tell me there's 1. The charge of manganese you're looking for, X, plus how many Cl's are present? There's 2 moles. The charge on Cl, did you memorize that rule? Cl's location, it's in group 17. It's a halogen. Its charge equals -1 in a compound. This whole thing has a sum equal to 0. Solve for x. X plus -2 equals 0. -2 equals 0. X equals +2. Manganese charge equals +2. So this would have been +2 for manganese. Cl's charge is -1. Can you still solve for those oxidation numbers? I know we did at one time, but could you still do that? If you can't, you have to obviously revisit this unit and analyze those rules again. Look at the examples. Make those connections. Could you still do all that stuff there? All right, next up, let's figure out what's going on with manganese. We found the charges. The charges go from +4 to +2. +4 to +2. Oh, definitely +4 or +2. So it's got to be either A or B. C and D don't make sense there. And from manganese +4 to +2. Mn +4 to manganese +2. We want to know, is it oxidized or is it reduced? Think about it. It's going from a +4 to +2. That charge is getting smaller. That charge is getting reduced. How does that charge get reduced? Is it going to gain electrons or lose electrons? Think about that. The charge is getting smaller. If I take a negative charge on, put a negative charge on, take another charge, negative charge on, I'm becoming more negative. If you take more electrons in, it becomes more negative. So you have to gain electrons. This situation, it's becoming reduced, or GER, gaining electrons, is reduced. Oxidation numbers are reduced, therefore it's reduction. Best answer here is going to be reduced, and the oxidation numbers changes from +4 to +2. The best answer is choice A. 2 is A. Next up, number 3, base your answer to the following question on the information below in your knowledge of chemistry. The diagram and the ion equation below represent an operating voltaic cell. All right. State the purpose of the salt bridge in completing the circuit in the cell. What's the purpose of a salt bridge? Anybody? Throw in the chat. Anybody know? Allows ions to flow. Someone in class said allows ions to flow. Thanks, Nadina. Yeah, that's it. The purpose of the salt bridge, it allows ions to flow. If that salt bridge is not there, the reaction is not going to happen. Electricity will not be created. Allows ions to flow. It connects the two systems. It allows ions to flow between the two chambers. Good. That's it. That would have been a short answer question on the regions. Salt bridge allows ions to flow. Could you still figure out which one the anode is? Could you figure out which one the cathode is? Do you know the flow of electrons here? Do you know the conversion of energy? Those are all fair game questions that you should be aware of for voltaic cells. Next up, another voltaic cell question. A student constructs an electrochemical cell during a laboratory investigation. When the switch is closed, electrons flow through the wire through the external circuit. The diagram and ion equation below represent this cell and the reaction that occurs. State the form of energy that is converted to electrical energy in the operating cell. What is the converted energy? So again, the question says, state the form of energy that is converted to electrical energy. What's converted to electrical energy? Please record your answer in the chat. What do you think the answer is? What to electrical energy? What is the conversion? Cool. Yeah. Several of you guys figured this one out. The conversion of energy is going to be chemical to electrical energy. It's creating electricity, voltage. The voltage allows you to charge your phone or use it for electricity. If these chemicals do not react here, though, that's the first part of the equation. If the chemicals don't react, then electricity will not be created. The answer here should have been chemical energy. So chemical energy. Best answer for 4 would have been chemical energy. Number 5, another voltaic cell question. It says when the cell operates, the electrons flow from what? Let's really get into this equation. Let's get in this diagram. Let's label this one. This question wants to know about the flow of electrons. How are electrons flowing in this situation? So I'm going to use my reference table. Why? I'm going to figure out which one's my anode and which one's my cathode. Let's label this again. Table J. On table J, we can figure out which one's the anode and which one's the cathode. So it says activity series. We saw this before. And we said finding the anode, finding the cathode was pretty easy because we said A stands for anode. Anode is above the cathode, just like the alphabet. Anode is higher than the cathode. Just like these metals here. Find the two metals. All right, we have zinc and we also have copper. Zinc and copper. The one higher up is the anode. The one that's lower is my cathode. Oh, we just figured out which one's the anode and which one's the cathode. Zinc is the anode. Copper is the cathode because it's lower. Let's label this up some more. So we have this cell, voltaic cell. We're going to label this up. All right, zinc was higher up, therefore this is my anode. The charge of anode in a voltaic cell is negative. The cathode was lower on that chart. It is a positive charge. Cathode was positive here. Make some connections. We have red cat and an ox. Red cat and an ox. What does that mean? Reduction occurs at the cathode. So make the connections. Cathode, cathode, red cat. Use the wrong colors here. And an ox. Anode is a site of oxidation. Make some more connections. What's the other phrase? Leo. Leo, loss of electrons, oxidation. Match it on up. Says GER, the gain of electrons is reduction. Connect those two R's together. GER, reduction. The flow of electrons. Electrons flow from anode to cathode. They always flow from anode to cathode. Electrons flow from anode to cathode. So what specifically is my anode? It's this rod. This rod right here is my anode. This other metal rod is my cathode. Electrons flow from anode to cathode. So they flow through the wire. They flow from anode to the wire, go through the voltmeter, work their way through the voltmeter. They flow from anode to the cathode. What happens here? As those electrons flow through the cathode, this cathode is going to have abundance of several electrons on there. Therefore, this rod's going to be mainly negatively charged. The zinc rod is going to be mainly positively charged. This is going to create the electricity. So what's going to happen to the cathode rod? The cathode, check it out. The cathode is actually going to take some ions in. This positive 2 ion is going to attract to this. This positive 2 is attracting this because positive and negatives attract to each other. So you can see that that's going to create the electricity. You should know all this portion, all this stuff about a voltaic cell. Chemical to electrical energy. You should know there's a salt bridge, which has ions flow. Voltmeter tells you the voltage. And the solution inside is electrolytes. Electrolytes allow ions to flow. There's free mobile ions in there. Best answer here, after I got rid of the whole picture. We want to know the flow of electrons. Electrons flow through the wire. The wire. So it's got to be A or C, not the salt bridge. Ions flow through the salt bridge. Electrons flow from the anode to the cathode. Zinc to the copper. So best answer here for this question is choice C. C is the best answer. Could you do all that stuff for a voltaic cell? If not, check out your notes. Next up, number 6, the diagram picture shows a spoon that will be electroplated with nickel metal. What occurs when switch S is closed? Close the switch. What's that mean? That means a switch right here. So this is a circuit. It's connected to a battery. This should be connected here. It's connected to a battery, but there's a switch right here. It's open right now. I mean, no electricity can pass through. It's like the light switch is off. Turn the lights off. There's no electricity. But once you put the light on, the switch is now going to be closed. So if I take that little switch and close it, it would look more like this. Once it's closed, it's going to go on. If you like learning about circuits and electricity, there's a whole unit in physics. Maybe that interests you. But anyways, this is an electrolytic cell. In an electrolytic cell, there's one chamber. There's a battery. The conversion of energy goes from electrical energy from the battery to chemical energy. I did an example like this in class. I took a nickel and I took a penny. I took the copper off the penny and plated it onto the nickel. Could you label all the portions of an electrolytic cell? Here we go. First thing I would do is label and look at the battery. The battery tells you the anode and the cathode. We have a negative charge here. The negative charge in the situation is going to be a cathode. So the cathode in this situation is going to be negative. The only time all year the cathode is negatively charged. Why? Because you have a battery. So follow that wire. switch is closed. My spoon is going to be my cathode. The anode is going to be my positively charged metal. So this nickel is going to be my anode, which is positively charged. From there, connect these phrases, connect the phrases, the corny phrases that we talked about. Red cats in an ox, red cat, reduction at the cathode, and an ox. Anode is a site of oxidation. Also, you have Leo says Gur. Leo, loss of electrons, oxidation. Gur, gain of electrons, is reduction. The flow of electrons, we know, it's going from anode to cathode again. It's got to go anode to cathode. It always goes from anode to cathode. Electrons go from anode, which is my nickel, goes through the wire, goes through the battery, goes through the other wire, and it goes all the way down to the spoon. My electrons flow from anode to the cathode. If electrons flow in this direction, my spoon is now going to be mainly negatively charged. There's going to be a ton of negative electrons just chilling and hanging out in the spoon. It's negatively charged. This negatively charged spoon is going to attract some nickel. So this nickel is going to be mainly positive. But if you forgot the flow of electrons, you can look at this and say, oh, Leo, the anode's losing electrons, and Gur, the cathode's gaining the electrons. That could help you forget the flow. So what's going to happen here? This spoon that is negatively charged is going to attract some positively charged nickel to nickel plate the spoon. Electrolytic cell, you can see what's happening here. The spoon is not going to lose mass. It's taking on more nickel. It's going to have to gain mass. So it's definitely not choice B or A. It's going to have to gain mass. And it wants to know, is nickel reduced or is nickel oxidized? There's my nickel. Oh, we made these phrases. We put the phrases together. There's oxidation. There's oxidation. It's definitely going to be oxidized. Choice D is the best answer for this question. Could you still do electrolytic cells? Could you do voltaic versus electrolytic cells? If not, check it out. Choice D is the best answer for number 6. Number 7, now on to acid, bases, and salts. Unlike an acid, an aqueous solution of a base, what? What's the best answer for number 7? Feel free to use your notes if you need to. Find it in the notes. Unlike an acid, an aqueous solution of a base, what? Please record your answer in the chat. Base. Nobody? Base. Oh, there's a base. When do you know the answer? All right. A base contains, someone said D, contains more OH negative ions. Yeah, that's the right answer. So if I check out the pH scale, we should know a base. What makes a base a base? It's OH negative. What makes an acid an acid? It's the H plus. If I look at my pH scale, if I look at my concentration of OH and H plus, right there, strong bases. Thanks, Nadina. Thanks, Jordan. High concentration of OH contains more OH and low concentration of H plus. A base is going to have more OH, less H plus. 7, the best answer is choice D. 7 is D. Nice job if you answered that correctly. Number 8, when a arrhenius acid is dissolved in water. Acid dissolves in water. What happens? Basically, wants to know what's an arrhenius acid. Arrhenius acid, There it is. Arrhenius acid, H plus, or hydronium. H plus is the only positive ion in the solution. Acid, H plus. Choice A is the best answer for number 8. Number 9, which substance, if added to a saturated solution of NH4OH, would cause the pH of the solution to increase? We want the pH of the solution to increase. We want to increase in the pH. So the first thing I would think about is the pH scale. Do you know the pH scale? First thing I would think of is the pH scale. The range of the pH scale goes from 0 to 14. 7's in the middle, that's neutral. And then greater than 7 is going to be 14, which is going to be a base. You have the acid 0 to 7. And 7's your neutral point. Strong bases, strong acids. Weak acids, weak bases. Question again. Which substance, if added to a saturated solution of NH4OH, would cause the pH of a solution to increase? We want to increase in the pH. It's got to be something with a higher pH value, maybe a 14, maybe 13. Something with a higher pH value is going to be a base. We're looking for in the question something that is going to be a base that's going to make a higher pH value, increase pH value. We're definitely looking for a base. It's going to increase the pH. Now, we're going to have to figure out which one's an acid, which one's a base. Look at the reference table. There's a page on the reference table regarding common acids, common bases. Oh, HCl. HCl is a common acid. That's going to reduce the pH. That's an acid. No. NH4Cl, next choice. It's not here for common acids. It's not here for common bases. That's a polyatomic ion. If it's not on page 6 of the reference table, common acids, common bases, if it doesn't have an H plus or OH negative, it's not going to be an acid or base. It's not going to reduce or change the pH level. Choice C. Let's check it out. We have lithium, which is a metal, and OH, which is hydroxide. Lithium, which is a metal, and OH, which is hydroxide. Oh, NaOH, KOH, CaOH. Metal plus hydroxide. Metal plus hydroxide. Metal plus hydroxide. A metal plus hydroxide. A metal plus hydroxide. A metal plus hydroxide. That is going to qualify for a base. That is a base. Best answer is going to be choice C. You're probably saying, hey, why isn't it choice D? Because that's not a metal. CH3 is not a metal. And OH, you're probably saying that's hydroxide, but it's actually alcohol when it's bonding with organic compound. We'll see that soon in class. That would be like C with 3 H's around it. It's methanol. And then in OH group, a functional group, it's going to be like this topic right here, topic number 5. We didn't get to that, but that's going to be an alcohol attached. Best answer here is going to be choice C. Next up, number 10. Wants to know which one's neutralization. Neutralization is going to be an acid plus a base yields salt plus water. First thing I would look for is water as a product. If there's no water at the product, then it's not going to be the right answer. Choice A, there's no water as a product. Choice B, there's no water as a product. Neutralization, acid plus base yields salt plus water. All right. Looking for acids. Looking on the reference table, that's an acid. So is HNO3. That's an acid. Next up, look for a base. KOH, metal and OH, that's a base. CaCO3 is an ionic compound. It's a polyatomic ion, not a base. This would be your salts, yield salts plus water. D is the best answer. Neutralization, acid plus base yields salts plus. Number 11, a couple more questions. If the pH of a solution is 9, the solution is what? B? D, basic. So from pH scale goes from 0 to 14. Someone said it's D. Let's check it out. This is definitely going to be the base. So it's C or D, true. We want to know about phenolphthalein. Phenolphthalein, is it going to turn pink or is it going to turn colorless? The pH is 9. Let's check it out. Reference table, here we go. Indicators. Scroll on down, phenolphthalein, we did an example on this. How do the indicators work? Indicators, here's how they work. Check out phenolphthalein, we don't care about anything else but phenolphthalein. If it's 0 to 9, the pH is 0 to 9, 0 to 8, not 9. If the pH is 0 to 8, the solution is going to be colorless. If the pH is 9 to 14 in this window, this range, 9 to 14, it's going to turn pink. The pH in this example says pH of 9. There's 9. It's going to turn pink. It's going to be basic and turn phenolphthalein pink. 11, the best answer is choice C. 11 is C. And the last question is about titration, but maybe we won't know that when there's the whole year content and formulas in there. It's easy now because we only have 2 different units to analyze. We know we're talking about acid bases. This one might be tougher tomorrow if you have a question like this. If you have a tough question, I would suggest figuring out what the heck you have, figure out what is given to you in the question, figure out what they're asking you to solve for, and then find an approach. I've been saying that all year. Figure out what you have, figure out what they're asking you to solve for, find an approach. All right, let's go through the given information. It says how many milliliters of a 5 molarity NaOH are needed to exactly neutralize 40 milliliters of 2 molarity of HCl. Oh, how many milliliters? That's definitely important. We have 5 molarity of NaOH, important. We have 40 milliliters of volume, that's important, and we have 2 molarity of HCl. So tomorrow you're trying to figure out which formula to use. You're pulling out the given information, given info on scrap paper, and you realize how many milliliters you're looking for. Milliliters. Milliliters is going to be a volume. Hopefully you can make that connection. Volume of what? Volume of NaOH. OH is a base. Oh, volume of the base. Volume of the base is going to be, hey guys. Just want to say hi. Oh, great. Hi, Emma. Thanks, Jumila. Appreciate it. I let somebody in and it messed up my whole screen. But someone just got booted out, so hopefully it's not her again or him, whatever. All right, so again, how many milliliters of Zen? Hi, Zen. Hope you're doing well. Highlight the important information. All right, back to the given information. Let's go Bumblebee style. They're coming out now. Given information. The volume of the base we're looking for. Next piece of information is 5 milliliters. 5 molarity. Molarity is a concentration. Molarity, big M, match them on up. Molarity of the base equals 5.0. Next piece of information we have 40 milliliters. Milliliters is a volume. Volume of what? HCl. HCl is going to be an acid. That equals 40. Last piece of information, we have 2 molarity. That's going to be molarity of the acid. Maybe we didn't know it was going to be acid and base question. By now, you should know HCl is a common acid. By now, you should know OH is going to be a base. So we pulled all that information from the question. Now I'm going to look at the last page of the reference table, figure out which formula to use here. All these formulas, trying to differentiate, figure out which one's the best formula to use. We have volume, we have molarity. We have neutralized there as well. Oh, we have volume. That M's not molarity, it's mass, definitely not density. We have moles, no, nothing there. Percent air, no. Percent by mass, no. ppm, no. Molarity? Huh? Oh, molarity equals moles of solute per liters of solution. We have molarity, we have liters. We don't need moles. We need a volume. Not going to work out. Getting closer. Scrolling on down a little further. Titration, molarity, volume, molarity, volume. Molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. That is the formula we will have to use here. Plug it on in. Molarity of the acid times the volume of the acid equals molarity of the base times the volume of the base. I think there is a question on titration tomorrow. Molarity of the acid, 40. Nope. Molarity of the acid, 2. Volume of the acid, 40. Molarity of the base equals 5. Volume of the acid, volume of the base is X. Solve for the expression. 2 times 40, 80, equals 5X. Get X alone, divide by 5. Divide by 5. Use a calculator. Don't make a simple mistake. Use the app. You can use your cell phone. You can use an old school calculator. 80 divided by 5. 16. 16 is the best answer here. Could you still do titration questions? All right, you can submit your work. You don't have to. But this is review for unit number 8 and unit number 9. Acids and bases and redox reactions. Oof. Oh. Didn't grade them short answer questions right. But that's okay. I'm not grading this. This is more for you guys to review. Tomorrow is where we do grade your assessment. Hopefully you're ready for it. Any questions for me? So the highest score you can get is going to be a 10 out of 12 in that if you submit it, but it's not going to your overall grade. All right, hopefully you're ready. Did a lot of review. Took a lot of time away from class for that review. Hopefully you got something out of it. Put your effort in. All right, please open up your guided notes. Let's finish up the review, I guess we'll say, and go through organic chemistry. Let's figure out how to name organic molecules. So we talked about this last class. We're on unit number 10, organic compounds. I hope you feel that way. I'll see you after tomorrow if you feel the same way. Organic chemistry, we talked about organic basics. We talked about hydrocarbons. We talked about topic number 2, homologous series. We talked about isomers. We talked about naming organic compounds. Topic 5, topic 6 are not going to be on the post test. Here we go. Organic compounds. We said Organic compounds are going to be carbon atoms or carbon-containing compounds. They're covalent bonds. Carbon atoms are very popular. They're very reactive elements because there's 4 electrons, 4 valence electrons, and there's room for 4 more electrons to bond there. Organic compounds form chains, rings, or networks. So 4 more things combine with a carbon atom. We talked about organic molecules being a single bond and saturated. We looked at the example for butane. We know that but refers to 4 carbon atoms. 1, 2, 3, 4. Ane tells you that there's single bonds in between. That is a saturated hydrocarbon. We looked at 1-butene. Ene told us that there's a double bond. We're at carbon number 1. We number the carbon atoms from the side closest to a double bond or a triple bond. So this is carbon 1, this is carbon 2, 3, and 4. At carbon number 1, there's a double bond. We looked at 1-butene. But told us that there's 4 carbon atoms. The ine told us that there's a triple bond. Ane, ene, ine. At carbon number 1, there's a triple bond there. We'll look at naming these a little bit more today as well. We looked at molecular formulas. A molecular formula tells you the total number of atoms in a compound and the type of atoms in a compound. Empirical is the simplified. We looked at structural formula, shows you the shape and the types of bonds are in a compound. We looked at a condensed structural formula. A condensed structural formula tells you what's attached to each carbon atom in a compound. And a ball and stick model tells you the shape, tells you what types of bonds are going to be within a compound and the type of atoms in a compound. We know a hydrocarbon is going to be a hydrogen and a carbon only in an organic compound. We talked about prefixes. They're on the reference table. We talked about topic 2, homologous series. A homologous series is an alkane, alkene, alkyne. Ane, ene, ine. Single, double, triple. A, E, Y. Single, double, triple. Saturated, unsaturated, unsaturated. An ane is a single bond. It's saturated. The ending is going to be ANE. We looked at the formula CnH2n plus 2 for an alkane series. An alkene is a double bond. The ending is ENE. The formula is going to be CnH2n. We looked at examples on that. And an alkyne is going to be a triple bond. It's unsaturated, triple bond. The ending is YNE. The formula is CnH2n minus 2. We talked about an isomer. Isotope, same element, different number of neutrons. An isomer, same molecular formula, different structural formula. Same molecular formula, different structural formula. Isomer. We talked about naming organic compounds. We talked about naming straight chain organic compounds. Easy. Straight across. Count the number of carbons. Number of carbons is going to be the prefix on the reference table. But tells you 4. Ending, ANE, is going to tell you if it's a single bond, a double bond, or a triple bond. We analyzed how to name some straight chains. And then when you guys had the AP Euro test, we went through and we named a branch chain hydrocarbon. So a little bit more complicated. We figured out to name or figure out the longest continuous carbon-to-carbon connection. We did that. That's the parent chain. We figured out what's attached to the parent chain. There's a couple different groups attached there. We have a group on top. We have a group on the bottom. These are called substituent groups. And then we named them by the prefixes on the reference table. There's 1 carbon atom attached there. That 1 carbon atom would be a meth. And with that group, we had O. The one below has 2 carbon atoms. 1, 2. And that would be like F. O. The ending for substituent groups are YL. We named those substituent groups. And then I told you we had to number these organic molecules. Number these organic molecules, the parent chain. How do we number the organic molecule or the parent chain? You number it from the side closest to a double bond or a triple bond. If there's no double or triple bond, you number it to the side closest to where there's a substituent group. There's a group, it's closest to the left. We're numbering it from left to right. Substituent group must be numbered from left to right. Hence, the reason why we numbered 1, 2, 3, 4, 5, 6 from left to right. There's a methyl group, there's an ethyl group. The parent chain has 6 carbon atoms. Therefore, it's going to be hexane. Ane tells you that there's single bonds between the carbon atoms. We did that. We named this. We figured out how to name this thing. We said it has to be in alphabetical order. The substituent groups have to be in alphabetical order. And you have to indicate where the substituent groups are with a numerical value. We said that example above was 3-ethyl 2-methyl hexane. And then once you've understood how to do that, you felt amazing because you're amazing. You figured out how to name an organic compound, a branch chain organic compound. You roll around with a branch chain organic compound like that, people are going to look at you a little funny, but that's awesome. They're going to look at you like you know what you're doing. Go show that to someone. Say, hey, could you name this organic compound? You could. 3-ethyl 2-methyl hexane. Let's play and practice some more and figure out if we can name more organic compounds today. We named pentane. That was an easy one. 5 carbon atoms across, single bonds, pentane, straight chain. We named 2-methyl hexane last class. There's a substituent group off of carbon number 2 and hexane. We named 3-ethyl hexane last class. We named 3-ethyl 3-methyl pentane last class. And we ended up with this tough one. It was 2,4-trimethyl pentane. We named that one last class. Today's class, what we're going to do, we're going to take these names of organic molecules and we're actually going to draw these organic molecules. If you have a hard piece of paper at home, a white piece of paper, whatever, lined piece of paper, I would suggest taking that piece of paper out now, take a pencil out now, and we'll write these out. We'll draw these out on a separate piece of paper. So again, I would suggest writing them out on a separate piece of paper. For today's class, if you do not upload these images, I am not going to penalize you for not having them in there. So this is the only time all year I'm telling you, hey, if you don't have this portion in there, it's fine. But I do expect you to still draw these out at home. I'd rather have you focusing on drawing these out by hand at home. It would take forever to put them in Google Docs, the drawing. I'm not doing that. So the rest of the class, I'm going to take these examples. We'll go through 4 examples or maybe 3 examples today. We'll see where we're at. We're going to take these examples. We're going to draw them out on a separate piece of paper. So you do need a reference table. You do need scrap paper. Let's figure out how to draw 2,3-dimethyl-2-pentene. Here we go. Oh, there's my love. Back in the day. It's good stuff. All right, here we go. I'm going to take some scrap piece of paper. I'm not going to share that screen. Some room over here to work. Boom. Examples. Reference table. Pencil. If we're in school, I would be using the Elmo all the time. Love the Elmo. Love showing you where to find things in the reference table, flip this page, but we figured it out in the virtual world. So we need page 7, the reference table. Scrap paper, good to go. And the first example, I'm going to write out the name of the compound above. Then we'll figure out how to draw this thing. So it's 2,3-dimethylpentene. Right up, 2,3-dimethyl. 2-pentene. A little blurry. All right, the first thing you want to start off is the parent chain, the parent name. Pretend this is someone's name, says Jeffrey Brown. There's a first name, there's a last name, Jeffrey Brown. Instead of Jeffrey Brown, this is dimethylpentene. Okay, I think we're in focus. So instead of being Jeffrey Brown, first name, last name, this is dimethylpentene. Brown is a last name, pentene is a last name. This is the family name. So in the Brown family or in the pentene family, there's several kids. So I'm the youngest of 4 children. In the Brown family, there's 4 other kids. They all have different names up there or different substituent groups. So we're starting off with the family name, pentene. In pentene, we have pent, which tells you there's 5 carbon atoms. Pent is 5. Start off with 5 carbon atoms across. The pentagon has 5 sides. Pent has 5 carbon atoms straight across in a straight chain. 1, 2, 3, 4, and 5. The next thing I would suggest to do is to number these carbon atoms. All right, I'll number this one carbon number 1. Inside that little C, I'm going to put the numbers. Carbon number 2, carbon 3, carbon 4, and carbon number 5. Next up, so I took care of pent with 5 carbon atoms, done. The ene tells you that it belongs to homologous series for a double bond, alkene series. Where's the double bond? It's going to be at carbon number 2. Carbon number 2, there's going to be a double bond which connects from carbon 2 to carbon number 3. Okay, ene's done, my number's done, good. Last name's done, parent name's done. But connected to the parent chain is going to be a methyl group. So 2,3-dimethyl. Di tells you that there's 2 different groups. There's going to be a methyl group. Di tells you there's 2 methyl groups. 2-methyl. There's a methyl group at carbon number 2. There's a methyl group at carbon number 3. So there's 2 methyl groups, one at carbon number 2, one at carbon number 3. So find carbon number 2, boom. At carbon number 2, we have a methyl group. What's meth? Meth is going to be 1 carbon atom. So at carbon number 2, we have 1 carbon atom attached. Could you attach it to the top? Could you attach it to the bottom? I don't care. Either place, as long as you have it there, you're good to go. So carbon number 2, you have a methyl group. And carbon number 3, that one's done. Carbon number 3, you have a methyl group 2. This one I'm going to put below. Meth is 1 carbon atom. Done. All right. Finished up that. We're good to go. The last thing you have to do is put the H's around this. Each carbon atom has to have some hydrogens around it. So each stick in the situation represents a pair of electrons. On this stick, there's going to be 2 electrons. This stick, there's 2 electrons. This stick, there's 2 electrons. 2 electrons in this stick. 2 here, 2 here, 2 here, all the way across. Each stick represents 2 electrons. The sharing of 2 valence electrons. Every carbon atom is going to need 8 valence electrons total. So first off, carbon number 1 has 2 electrons. It needs 6 more. When there's a single bond, it's pretty easy to think about. There's a single bond in carbon number 1. There's 2 electrons. You need 2 more at the north, 2 more at the south, 2 more at the west. On each stick represents 2 electrons. Let's just focus on carbon number 1. Is that stable? 2, 4, 6, 8. Oh, there's 8 electrons around it. That's going to be stable. The last thing you have to do is put the H attached to the end. So H is going to bond with that too. Let's check out carbon number 2. All right, carbon number 2 so far. Carbon number 2 has 2, 4, 6, 8. Oh, there's 8 electrons on carbon number 2. That is stable. Good. Not touching it, not adding any more sticks, not adding any more H's. Let's focus on the carbon above. Carbon above right now has 2 electrons. It needs 6 more. There's going to be one to the north, a stick to the north, a stick to the east, a stick to the west. On each stick is going to be 2 electrons. This is going to make a stable octet for carbon, sharing electrons. At the end of each stick is going to be an H. Carbon number 3, let's see if it's stable. Carbon number 3, is it stable? Check out just carbon number 3. Electrons. 2, 4, 6, 8. Stable. Good. The one below, it's got to be a stick in north, south, east, and west direction. H, H, H. At the end of the stick is going to be an H. Get rid of all my extra stuff now. So again, at the sticks, on the sticks, there are going to be 2 electrons shared. When it's a single bond, it's super simple. There's 2 electrons, 2, 2, 4, 6, 8. At the end of the sticks are going to be H's. No, you don't always represent these little dots on the sticks. I'm just showing you for the first example so you can see what a stick is representing. How many electrons are there? Single bonds is super simple. You need to have a stick to the north side, the south side, the east side, the west side. This right here would be 2,3-dimethyl-2-pentene. 2,3-dimethyl-2-pentene. You could represent it like that. Or you're going to get sick of writing all the H's all the time. Another way you can represent this, think about it again. Look at pentene. Pent is 5 carbons. 1, 2, 3, 4, 5. I'm going to number it. At carbon 2, there's a double bond. Done. At carbon number 2, there's a methyl group. Methyl group. At carbon number 3, there's another methyl group. And last thing you have to do is put the H's around it. Again, how do you represent the H's? Each single bond is going to have a stick to north, south, east, and west. Carbon 5 is done. Carbon 2, north, south, east, west. Good. Each single bond has a north, south, east, west. Each single bond, oh, it's not single, 2, 4, 6, 8 for carbon number 3. Carbon number 2, check out the sticks closest to it. There's 2, 4, 6, 8 closest to it. The one above, single bond. Last one, carbon number 1, is a single bond. You can represent 2,3-dimethyl-2-pentene just like that. As scientists, as chemists in organic chemistry, it is known that there's going to be an H attached to each one of these sticks. Again, either one of those situations would represent 2,3-dimethyl-2-pentene. Let's try out another example. Example number 2. 2-methyl-4-propyl-3-heptene. Wow. That's awesome. 2-methyl-4-propyl 3-heptene. It's in the notes. 2-methyl-4-propyl 3-heptene. First things first, start off with a parent chain. Last name. Start off with the last name. Use a reference table. What is hept? Look on the reference table. Hept is 7. Start off by making 7 carbons straight across in a straight chain. 7 carbons straight across. All right. 1, 2, 3, 4, 5, 6, 7. Number the number of carbons that you have. All right. Carbon 1, carbon 2, 3, 4, 5, 6, and 7. Cool. 7 carbon atoms. There's my hept. Done. Ene means a double bond. Where's the double bond? At carbon number 3. Carbon number 3 has to have a double bond. It's going from single, not to double. All right. Ene is done. Now you can start. I don't care if you start for propyl or if you want to start at the beginning. I'll start at the beginning. 2-methyl. There's a substituent group on carbon number 2. I'll make this one go above. Carbon number 2 has a methyl. Meth tells you 1 carbon atom. Ol tells you a substituent group. All right, that's done. And at carbon number 4, there's a propyl group. Carbon number 4, prop. Prop refers to 3 carbon atoms. Carbon number 4, there's a propyl group. Carbon number 4, there's 1, 2, 3 carbon atoms attached to that, 2. The last thing you have to do is put the sticks to represent the H's to make sure it's a stable octet. How do you do it? If it's a single bond, you need one in the north, south, east, and west. Carbon number 7, north, south, east, and west. Carbon 6, my east and west are covered, but not the north and south. Carbon number 5, east and west, 2, 4, 6, 8 electrons for a stable octet. Carbon number 4, let's check it out. 2, 4, 6, 8. Oh, that's stable. But below it, they're not stable. Single bonds, you need a stick to the north side, south side, east side, west side. Carbon number 3, is it stable? 2, 4, 6. No, I need one more. 2, 4, 6. I need one more. One more stick. You go to north side or south side. Pick one or the other. Carbon number 2, need one more to the south. The one above, the methyl group above, you need north, east, and west. And the last one, carbon number 1, north, south, and west. Are they going to give you a question like this on the post-test tomorrow? No. They're not going to say, draw an organic molecule for 2-methyl, 4-propyl, 3-heptene. They could give you a question where they give you a structural formula, or they might give you like a name and say, what kind of molecule is this? And you're going to tell them it's an organic molecule. So as long as it has carbon and hydrogens in there, so it looks like a long chain, it's an organic molecule. Are we going to have to know how to draw these tomorrow? No. But they might say, what kind of molecule is that? Organic. An organic molecule. Hopefully that helped with a little bit more practice with naming organic molecules and drawing organic molecules. At this point in the game, I'm not going to go any further and do another example. There's not that much time left in class. So from here on out, my mask is definitely crooked. Hey, hi guys. I'm in class there today. Reminder, you do have a post-test. Units number 1 through unit number 10 are all fair game on the tests. 32 multiple choice questions. You have one more day to review for the test. All right, guys, that's it for today. Have a great day. Hopefully you guys are ready. Preparation is the key to success. Have a good day. Make decisions. Stay safe. Bye, guys. Prepare yourselves. Bye, Nadine. Bye, Jordan. Have a good day. Bellman, hopefully you're mean that. I appreciate that, though. We'll see you tomorrow. Benchmark tomorrow. See ya. Bye, guys.